Alright, we're going to go over the quiz number 4, which we just did. We're going to go over some of the answers so that if you didn't do so well in the quiz, you know where you went wrong, and hopefully this will also provide you a reminder for some of the main rules that we're going to be using a lot for the rest of the quarter. So it's definitely important to make sure that you go over these and that you understand these. So let's start out with number 1. So this is question number 1 on the quiz. And the thing we had to derive was a conditional. So this was of the form if D, then if G, then E. So this is what we actually had to derive. And the assumption we were able to have at the beginning, so let me just write line number 1 here. The assumption, the first primary assumption that you had was conjunction. So a conjunction in the antecedent, right? So this is D and G. And so if that conjunction holds, then the consequent. Okay, so how do we go about deriving this up here? Well, you notice that the main connective here is a conditional. And so right away, as soon as you see a sentence that you have to derive of this form that has a conditional, immediately you should think of setting up a conditional proof. And so the way you set up a conditional proof is by assuming the antecedent and then deriving the consequent inside the subderivation. So if G, then E. And actually, let me also write down here what our goal is. This is what we want to derive. So if D, then if G, then E. So this is what we actually want to derive. And a lot of you were tempted to actually have this subderivation to let it have the form of this conditional. And I totally understand the temptation to do that, but the idea here is that this is the conditional that we want to derive, right? So here we were going to want to use conditional introduction. And to do that, we need to assume the antecedent, which is just D here, not D and G, because this is the conditional we want to derive. So we assume D here as an auxiliary assumption for subderivation, and the goal is if G, then E. But notice that this new thing that we want to derive in the subderivation is again just another conditional. So we're going to want to use conditional introduction for this sentence, and the way we do that is by doing another subderivation, where this time we assume G as our secondary auxiliary assumption, and our goal in this subderivation is going to be the consequent, namely E. Okay, so now what we need to do, and actually maybe let me write this here. So we're going to assume D for the purposes of conditional introduction, and then we have a second auxiliary assumption where we're going to do an embedded subderivation, and we're assuming this again for another conditional introduction, namely for this sentence right here. And so now we need to figure out, okay, how do we get E? This is the thing we now need to get. And you'll notice that E is the consequent here in the primary assumption that we have. So let me keep numbering these things. So our goal is to get E, and you'll notice that because it's the consequent of the conditional, we could use conditional elimination with 1 if we can get D and G. And lo and behold, we actually have D here as our first auxiliary assumption in this subderivation, and then we've made another assumption to get the conditional introduction here. We've assumed G, and both of these are accessible within the subderivation. So we can actually here write D and G by conditional introduction from lines 2 and 3. Oh, from lines 2 and 3. Sorry, that was just a mistake right there. Okay, and now that we have D and G, you can use conditional elimination. So now we can say we get E by doing conditional elimination, and the lines that we're going to cite are lines 1 and 4, right? Because here we have the antecedent for this conditional. So we cite lines 1 and 4. And now we just have to go back and fill in the justifications for each of these derivations. So here we had conditional introduction. Remember, we assumed G for the purposes of conditional introduction to get E. We have in fact done that derivation now, so we can go back and we can justify conditional introduction here from lines 3 to 5. And then lastly, we just need to provide justification for this last step in our derivation. And notice we're now moving outside of the scope of this first subderivation that we did. So we cite lines 2 up into line 6. And remember, conditional introduction basically says if you assume the antecedent of the conditional that you want to derive, and you're able to derive the consequent, which in this case is another conditional, then you can introduce this conditional here. So hopefully if you go back to looking at your quiz when I hand them back to you on Monday, you can have a look at how we did this derivation and compare it to the one you did in your notes. Okay, so let's do the question for number 2. So let me start all over again here. Okay, and this is for question number 2. And what we wanted to derive was a double negation. So our goal was to derive not K. That's what we wanted to derive. And we were given 2 assumptions at the beginning. The first one was if not K, then L. Then J. That's what we had. And the second assumption was if not K, then we had a conjunction as the consequent. We had not J and L. Okay, so these were our primary assumptions. And notice that the thing we want to derive is, let me just put a little eraser in there. The thing we'd like to derive here is a double negation, right? It's a not K. So there's 2 ways you could do this. You could, given that our goal is a double negation, you might assume a third negation in front and then derive a contradiction. Or we could also just use, we could assume not K and then use negation introduction, the negation introduction rule. And so then our goal would be to derive a contradiction. You can do it either way. And in fact, actually, as a general principle for a lot of these proofs, there's actually more than one way of getting to the thing that you want to derive. And the idea usually is to pick the shortest proof possible, because that'll be the one that's more elegant. So here, we're going to use negation introduction to get not K. And so to do that, we're going to assume not K, and then we need to derive some kind of contradiction, right? We need to derive some sentence Q, and then not Q afterwards. So as a first step, we see here that there's the sentence J, and then we also have the sentence not J. So it looks like that's a good candidate for a contradiction. And so we're going to try to pull that out. So you'll notice that given that we've assumed not K, we can use conditional elimination to get J out. So we can write J, this is line 4, and we can use conditional elimination citing lines 1 and 3, right? Conditional elimination says, hey look, if you have a conditional somewhere and you have the antecedent, and if both of those are accessible in your derivation, which in this subderivation they are, right? Because this is has a wider scope than this subderivation does, then you can introduce, or you can write down the consequent, which we've done here. Okay, and then similarly we can get the conjunction here, not J and L, using the same strategy we just did, right? We have not K as the antecedent, and we have this conditional. So again, we can cite conditional elimination for getting this derivation. So we cite line 2 and line 3 again. And notice that this is not yet a contradiction, right? What we actually need to do is get this not J out on its own. So we need to use an extra step here, and we need to say not J, and we're going to use conjunction elimination. And so for conjunction elimination, you just have to cite one line. So we just have to cite 5 here. And now we have a contradiction between j and not j, which is exactly what we wanted. Remember, so we assumed not k for the purposes of introducing a negation. So now all we have left to do, now that we've gotten this contradiction, is to fill in our justification for this last line. And this will be from the subderivation from 3 to 6. Okay, so that's how you do question number 2. Now let's do question number 3. And I'll pick one more different color. And I think this is probably one of the easier ones. And maybe 2 was, actually maybe 2 was even easier than this one. But let's just go over this. So our goal is to derive the sentence M. And we were given as primary assumptions, we were given either N or O. If N, then M. And if O, then M. And these were our primary assumptions. Just number them off. 1, 2, and 3. Okay, so one of the strategies we talked about is if you see that there's a disjunction in one of your premises, it's a good idea to try to use disjunction elimination. And in disjunction elimination, what you basically do is you show that by assuming N is the case, we can get M, and by assuming that O is the case, we can still get M. So it doesn't matter whether or not N is the one that ends up being true or whether or not O is the one that ends up being true. In either case, we can get M. So the way we set up disjunction elimination is just as we said. So we're going to assume N, and our goal is to try to get M. And then we're going to assume O, right? We're going to assume O this time, and our goal again is going to try to get M. And disjunction elimination says that if you're able to do this, then you can pull out M. You can use conjunction elimination as your justification for concluding M. So now what we basically need to do is, given that we've assumed this for the purposes of disjunction elimination, and this for disjunction elimination, our goal now is to try to get M in each of these subderivations. And this, once you have this set up, the rest is actually relatively easy. So you notice that, well, M is just the consequent of this conditional, and we have the antecedent of this conditional on the subderivation. So we can actually write down M, and we can use as our justification conditional elimination, and cite the lines 2 and 4. Right? Because conditional elimination says you need to have a conditional and you need to have its antecedent. And if both of those are accessible in the subderivation or in the derivation, if they're accessible within the scope line that you're in, then you can actually take out the consequent. And that's in fact the case. Okay, so now all we have to do is do that again for the case of O. And you might be tempted, well, look, maybe since I have M, I could just use reiteration right here. That might be something you might be tempted to do. But this would actually be not correct. And the reason why is because we are now in a different subderivation. And what happens in here is not accessible from this other subderivation. Only things that are in the outside of the scope of this subderivation are accessible to it. But that's no matter. I mean, it's still relatively easy to get M because we have this other conditional, namely if we have O, then we can get M. So we can do the exact same thing we did in this first subderivation, which is we can use conditional elimination, and we cite as justification line 3 and line 6. And that's totally okay, right? Because this conditional is in the outer scope of this subderivation. So we cite line 3 and 6. And now we're done, right? I mean, we just have to fill out this last justification here, but we've used conditional elimination by showing that, look, I can get M by assuming N, and I can get M by assuming O. And because I can do that, I can derive M, and here what I have to cite is line 1, right, the disjunction, and then the two subderivations that we had to do, namely lines 4 to 5, and then lines 6 to 7. Okay, so that covers the quiz questions from 1 to 3. In the next video, what I'm going to do is go over question 4 and say a little bit more about the nature of the rules that we've been trying to pick. So I'm going to spend a little bit more time trying to motivate why we're using some of these rules and not other ones, because I think this is a question that some people are having. Why is it that we're picking these seemingly arbitrary rules? So we'll see you in the next video lesson.